Greetings and welcome, friendliest of friends. We are continuing our solving multi-step equations with part 2, and we're looking at example 3. So it says solve the equation, and they say use structure. We'll see. I might do this distributing piece first, though. So we just had my students practicing distributive property. In which the idea is this, that if I have multiplication on the outside of parentheses, and if the only operations on the inside are addition or subtraction, then I can multiply that outside by everything on the inside. Now, my friend Devin, he'll tell you I do not distribute to this 3, right, Devin? Because that 3 is not on the inside, and Devin is completely right. Devin is right. So let's see. 2 times 1 would be 2. 2 times negative, I could view this as negative 1x, is going to be negative 2x's. This plus 3 is still hanging out, and I've got equal negative 8. So this distribution step is part of my simplifying before I start solving. Okay, and actually even for our survey says people notice that distribute is even an option that I have here. And after we distribute, we're going to actually combine like terms. We'll do some surveys in just a later problem. So does anyone see any like terms that I can combine here? Are there any x's that I can combine? No. How about constants? I can combine this 2 with this 3. And wait, can I combine the negative 8 with it? If they were on the same side of the equal sign, but I'm only combining like terms on the same side of the equal sign. Also, I like to write my variables first, so I'm going to write negative 2x. 2 plus 3 is 5 equals negative 8. And let's see now, 2 operations are happening to x. I've got multiplication by negative 2 and addition by 5. Which operation, Jimmy, do you think I should get rid of first? Now, according to PEMDAS, multiplication comes first, but I'm sad mapping. I'm working in reverse. You could divide by negative 2, but notice dividing by negative 2 is going to create a fraction, and I do not want fractions. You're not wrong. It's just going to be a hard way. You're going to have a hard problem ahead of you. So I recommend dealing with the addition first, so we'll subtract 5 from both sides. And it's not wrong. Like, you could literally write on your paper, like, divide by negative 2 and then be like, oh, I do not like that. I'm changing my mind, right? And choose a different path for yourself. Because we're solving for x, we're undoing everything that happened to the variable to eventually get the variable by itself and equaling some number. That's our goal, all right? So that's what we're trying. Let's see, negative 2x, the 5's canceled out. Negative 8 and negative 5 gets more negative. And let's see. Some people might say I add 2 to both sides here, but Pooja will tell you adding 2 is not how you're going to get rid of that negative 2. Yeah, we're going to divide both sides by negative 2, right? Because that's being multiplied, and the inverse operation of multiplication is division. Right, so we're doing the opposite operation in the opposite order. Yeah, craziness. So I'm going to get x equals negative over negative is positive. 13 doesn't divide by 2, friends. Well, Devin, good news. I can just leave that as 13 halves. That's a reduced improper fraction. I am all for that. That is a great way to leave our answer. As far as decimals, my general rule is if the original problem had decimals, then I'm fine with a decimal answer. Or if it's a word problem, right, you wouldn't be like, oh, I spent 13 half days mowing my lawn this summer. No one talks like that. You would give a decimal answer there. Here, Devin, you're getting distracted by that. You can shut that down maybe for now. Let's see, I will do a check with this. Just in case you don't believe me, I can plug this into the original problem. All right, and let's see what happens. 2 times 1 minus, oh dear, 13 halves, plus 3 is equal to negative 8. To combine fractions, oh dear, I'm going to need to get a common denominator of 2, right? You guys remember how to do that? We haven't covered any of that. I'm just going to do it quickly. You can go check out some other videos later if you want. But I would end up having 2 times 2 halves minus 13 halves plus 3 equals negative 8. 2 halves minus 13 halves is negative 11 halves, right? Amity. Shh. So I'd have that. What happens when I multiply? I mean, I had to deal with the fractions for a minute, but does anyone notice something wonderful when multiplying these? Those 2's cancel out. And so I'm going to have negative 11 plus 3 equals negative 8. And negative 11 plus 3 is negative 8. It worked out. So even though I had a weird answer, that answer was legitimate, okay? It worked in the original problem. It was a solution, is what we call that, right? It was a value of x that made the equation true. All right, so there's example 3. Let's look at some of the monitoring progress together. And so the first thing I do before I start moving things from one side or the next is, let's see, I'll shrink that down just a little bit, right like that. Look at that thing of beauty. The first thing I want to do is simplify. And so let's see, for example 4, what do you guys think? How could I simplify example 4? I can distribute. Right? And let's see, 3 times 1x is 3x. 3 times 1 is plus 3. I don't distribute to the 6, Devin would tell you, but that's so that plus 6 is just hanging out there. Equal sign, line them up, keep them in a column, equals negative 9. All right, let's see. Jimmy, do you see anything I can combine over here? Yeah, the 3 and the 6, those are what we call constants. They have no variable attached. Yeah, we can combine those. You're going to have 3x plus 9 equals negative 9. All right, let's see. Pooja, what would my next operation be? Now that it's all simplified, everything's distributed. Subtraction. I like it. Now, if someone wanted to divide, this problem would actually be okay. Right? Because this is divisible by 3, that's divisible by 3, and so is that. You would have been okay choosing the division path, but I like to just kind of recommend you guys commit to a simple path. Negative 9 minus 9, is that 0? No. Negative 9 minus 9 is more negative. That's negative 18. And then, let's see, Devin, how do I get rid of multiplying by 3? Yeah, division by 3 on both sides. Make sure you guys are writing this down. This stuff is gold. X equals, and negative 6, right? Yep, because the minus sign is still hanging out there. It didn't have another minus sign to become a plus sign with. All right, let's have you guys try problem 5. And I'll walk around and see how we're doing, and then I'll come back to my internet friends and see how they're doing. So, internet friends, you can try this one at home. The home version of Wadi Map. Let's see, internet friends. For question 5, let's do some distributing. This is a positive 4 that's being distributed here. So I'm going to have 15 equals 5 plus 4 times 2d is 8d. I think you're in the geometry playlist. That might be. And 4 times negative 3 is negative 12. Let's combine like terms, which would be the 5 and the negative 12. Right? Those are both constants. Neither of those have a variable attached to them. And so I'll have 15 equals, I'm going to write the 8d first, and 5 minus 12 is negative 7. Now, if you don't like the variable being on the right-hand side, you can choose to swap these right now. That's fine. But I'll solve for it on the right side, and then I'll swap it at the end. So let's see. What's my next move? How do I get d more by itself? Well, no, that 8 is being multiplied. Yeah, the 7. And to undo subtracting 7, add 7. Man, guys, I'm going to make you into the awesomest math, algebra, ninja force you've ever seen. This is going to be so great. We're going to, like, go solve crime using algebra. Man. People in Brattleboro will be afraid to do illegal things. They'll be like, no, the math force is going to get us. And that would be true, because we'd solve all the algebra-related crime. How do I get rid of this 8? Yeah, divide both sides by 8. And, oh, this fraction can be reduced. Those are both even. So I'm thinking 2 goes into 22 11 times and into 8 4 times. And I don't think I can reduce 11/4 anymore, if you guys agree. So I'm going to say 11/4 is equal to d, or d is equal to 11/4. Let's box it. Also, whenever I have a fraction that's got like an 11 in the top, it always looks like just some like sad face, kind of meh. Look at that guy. He's all just like, meh, I don't know. Look at that. Pretty great. No? You think so? Feel free to screenshot this from my YouTube video later and just, I don't know, you can make it your gamer pick or something for whatever you guys do. I don't know. Pretty great. It's all just like, meh. Such a meh fraction. All right, here we go. So I get d equals 11/4. Not bad, not bad. Let's see. These are so important. Let's try, oh, let's kick it up a notch. Let's try 8 and 9. Woo! You guys see those? Feel free to try 6 and 7 on your own time during an ace block or something. But 8 and 9, oh my goodness. Here, I'll do 8 here first. All right. So this, by the way, I want to point out, when distributing, the minus sign with the number on the outside goes with it. All right, so I'm going to distribute a negative 4 being multiplied by those things. So that's negative 8m, negative 4 times 5. Man, Devin and I messed up so bad earlier. I told him 4 times 5 was 40. Color me embarrassed. It's negative 20 in this case. Minus 3m equals 35. All right, let's see. Adriana, our new friend. What do you think the like terms are here? Negative 8m and negative 3m. I think she's been trained by another algebra master somewhere else. She knows what she's talking about. Let's see, equals 35. Jimmy, what operation do you think I should do to get m by itself? Division. I could, if I tried dividing by negative 11, that's going to create some ugly fractions. How could I get rid of this 20? Well, it's subtracting 20, so I want to do the opposite. Add 20, both sides. And notice when I say both sides, I'm always referring to both sides of the equal sign. I have seen students do this before where they'll be like plus 20, plus 20. That is super illegal. You just added 40 to one side and 0 to another. Okay? So I just want to point out, like, when I say both sides, I mean both sides of the equation. So let's see, I'll have negative 11. A is equal to 55. Let's see, what's wrong with this? Yeah, m is not being subtracted by 11. M is being multiplied, so the inverse would be to divide by negative 11, right? So I'm going to get m equals, you could reach for your calculator for this, but you would all know, of course, that it's going to be negative because there's only one minus sign. And then, yeah, 55 divided by 11 is 5. All right, this one, man, number 9. I'll let you guys try this one first. I'll walk around and see how you do. Oh, man, number 9. Delicious sleep. All right, mis amigos de internet. So my students are busy double distributing, right? Amity, you know how to do this one too, right? Oh yeah. So let's double distribute here. So 5 times 3 is 15 minus 5 times negative x is negative 5x. If it helps, you could remember to write the invisible coefficient in front of your variable. So you do the 5 times 1, that's where that 5 is coming from. 2 times 3 is plus 6. 2 times negative 1x would be negative 2x equals 14. Now, combine like terms. I can combine my x's, and I can combine my constants. All right? Lots of combination happening. Negative 5x and negative 2x is negative 7x. It became more negative. 15 and 6. Oh, that's why you said 21 earlier? Is that what you said or something like that? I don't know. Okay, here we go. Jimmy's going to tell us, how do you think, what should I get rid of first, the -7 or the 21? How do I even know? I don't know. 7 is being multiplied, and 21 is being added. So I want a SAD map. How do I get rid of subtraction or addition before multiplication? Yeah, subtract the 21, that's the inverse. Telling you guys are going to be awesome at this. So I'll have -7x equals -7. All right, signs were different. Be careful there. Now, is this what I do? Oh, man. I just keep wanting to, like, show you guys the classic mistakes that I see. So this is multiplied by -7, so the inverse is divide by -7. Also, sometimes people forget to put those minus signs there. They're just all like divide by 7. Make sure you're paying attention to that. And I get x equals 1. Wonderful, huh? Wonderful. Wonderful. All right, let's take a look at example 4. All right. Oh dear, what am I doing? Oh dear, errors, errors. Oh my goodness. Where's my all right, I don't know what's happening, but it's definitely happening. Okay, I'm just gonna screenshot this piecemeal. Okay, example 4. So, modeling with mathematics. Word problems, friends. When we're doing word problems, we do what's called VESA, VESA. Right? We define variables, we write an equation, we solve that equation, and we answer with words. So here we go. Use the table to find the number of miles X you need to bike on Friday so that the mean number of miles biked per day is 5. So my variable X, they actually already described it for us, is equal to the number of miles biked Friday. All right? Right? And the way I find that is, it's usually the question they're asking. Find the number of miles you need to bike on Friday. So that sounds good. And I already labeled my units was in miles. Right? Let's write our equation. Now, the equation, this one's sneaky, said mean. Mean. It's a type of average. I don't know if you guys remember how to find the mean. The mean is equal to, you add up a list of things, x1 plus x2 plus x3. Man, I'm writing that wrong. Plus ... plus x. Man, I ran out of space. Plus xn. You add up n many things, and then you divide by how many there are. All right, maybe you've never seen it written that way. That might be cryptic to you. But to find an average, right, I'm going to add up this list and then divide by how many are there here? How many things are here? 1, 2, 3, 4, 5 things. So let's write an equation considering the average. So I'm going to say x, because I like to put my variable first, plus 3.5 plus 5.5 plus 0 plus 5, all divided by the number of things, 5, and I want that average to be what number? There's a lot of 5s here. They wanted my average to be 5, so I want the average to equal 5. Yeah, this one. that was my. This problem is crazy. We should probably write it down. Is what I said in my. Is what I said. Feel free to also take that audio clip and make an awesome like dubstep video. Like Jimmy, you could add that as like background to any of your raps, any of them. Feel free. Like no royalties needed. Just use it. Make that your ringtone. Your phone will just go like every time. That'd be so great. Oh man, you'd be so pumped every time you get a text. So to solve this, let's combine some like terms. Let's combine. This looks a little crazy to me. I don't know. Does it look crazy to you? This looks crazy. I've got lots of constants here. 3.5 plus 5.5. This might be calculator work for some of it. That's fine. 3.5 plus 5.5 is going to be 8.5. 9 plus 0 is still 9. Plus 5 is 13. And now this one is tricky. You might be like, Mr. Waddy, we got to deal with the subtraction first. We should, or the addition first. We should subtract 13 from both sides. But the problem is 13 is locked inside this castle tower by this fraction bar. I cannot do that first. So I'm going to have to deal with the other operation being division first. Okay? What's the opposite of dividing by 5? Multiplying by 5. And I multiply both sides by 5. Notice how that helps me. Swipe, swipe, cancel, cancel. Right? I get x plus 13 equals 25. And now we can solve. All awesome. Subtract 13 from both sides. Oh, yeah. X equals 12. Now, if someone asks me this question, I'm like, x equals 12, right? They're like, I don't remember. What are you asking? You're crazy, right? We would be answering the question, right? The number of miles I need to bike on Friday. So I'm going to answer a word problem with a word answer, and I get that by combining this and this. And literally, the words can write themselves. Number of miles bike Friday is 12, right? And I could just program this computer to write this. So, or you could add a little bit of, poetry to it if you want. You could say, I need to bike 12 miles Friday, right? There you go. Now you've got a story. The people are following you. They feel you. Right, they get it. They're like, man, 12 miles. That's a long bike ride, right? That's what they'd be thinking. All right. Guys. Let's do example 5 quick. Tell you what, don't write this down. I'm going to just show it to you. All right, and you can always, if you want, watch this video later. Slow it down, listening to some smooth jazz, doing algebra. It'll be great. All right, your school's drama club charges $4 per person for admission to a play. All right, good for them. The club borrowed $400 to pay for costumes and props. Oh man, guys, I hope they have enough money. After paying back the loan, the club has a profit of $100. How many people attended the play? All right, step 1, define a variable. The variable is always related to the question being asked. Here, keep tracking with me. Actually, Pujik, would you mind closing the door? It's just getting a little noisy. Thank you for being so helpful. How many people attended the play? It sounds like I should make a variable related to the number of people attending the play. What's a good letter I could use for that? Yeah. Sure, P is for people. P is equal to the number, notice, how many people? So P should be a number of people attending. Yeah, I could use M, I could use X, I could use W for representing watt, watty, right? Don't pack up, friends. Keep tracking, keep tracking. Oh, only 5 minutes? Does that mean it's okay if I take only 5 minutes of your time later? Here we go. So let's write some equations. All right, let's see what facts I've got. It says they charge $4 per person. They borrowed $400, and then they have $100 left. Amity, could you help us write an equation relating these things? All right, $4 per person. So that's $4. If I multiply 4 by P, the number of people, this would represent what? The amount of money I get from selling tickets, right? $4 per person multiplied by people. The persons are going to cancel out, and I'd be left with dollars, right? Okay. And then I borrowed $400. So from this number, I should subtract 400. Borrow sounds like that was a debt. And afterwards, I was left with $100. So the remaining amount, Amity, would you agree is 100? So writing this equation required me to combine a whole bunch of different facts. A little tricky. So that's why, yeah, so try to notice. Well, it's a skill that takes practice. We'll get there. But right, notice I'm like kind of pulling this apart one piece at a time. But what you are good at is solving. Amity, how would I solve this for P? Amity, you got it. You got it. Don't worry, it's all you. All right, tag team. Pooja. All right, add 400 both sides. And I'll have, 4p is equal to 500. Divide by 4. Hold up. And we've still got like so much time. Oh, wait, oh no, we don't. Wait, yeah, we do. We got 5 minutes. Yeah. And let's see, 4 goes into 125 times. 25 times 5, 125 is what P is equal to. And let's see, what would the answer then be? Is that $125? How did you know that, Devin? Because I told us earlier, right? So I would say 125 people attended. And that's a word answer that answers the question of the word problem. All right. Thanks for watching, Internet friends. Have a great day.